Alright, so my topic was on threshold values, which are kind of like the one of the major components of a decision tree. It's the quantitative value that you put into any branch on a tree. So if this is our starting data over here, and we have two, branches off, right? What is the number? What is kind of the if factor right here that we're going to be using to, filter out everything? And so normally, if you could just figure it out, if there was no overlap, this process is really simple. You find the number that satisfies 100% of the time both sides. That'll have exactly what you want. So if we had maybe a data set of like A, like 4 A's maybe, and like 2 B's, right? And we want to separate this, and we were assuming that there are other qualities about the other data on whatever these are that we just don't understand, and we need to find a value, right, for one of these quantities that will separate them into the most homogeneous mixture. By that I mean like containing of all the same things. Okay, well, overlapping values, like, what do I mean by that, right? So let's say A had some sort of like length or something, right? And like all the A's had like 2.0 as their length. Like all the A's are 2, right? But then one of them is 2.5. And then all these other ones are 3's. All the B's, the B is 3, and there's also a B that's like 2.4. So we have an overlap in like this scenario here because we can't split it perfectly among them now. Like if we had a threshold value of 2.5, right, then we would accidentally filter this as with the A group. We don't want that to happen. So sadly, since we're only doing one thing at a time, it'll never be perfect. We will never solve this problem 100%, but we can find the value that gives us the best success rate. They're the most homogeneous thing, the one with the least information entropy. All these things are, talked about by the other students. But exactly how it does that is that it does this tree multiple times. It does this tree for all values such as this, so it'd be in a range. You'd have to give it a range of like 1 through like 4 or something, right? And it would go through all the values and see which ones yielded the best structures. So it would most likely end up as all the A's would get in here, but then there would also be a B, because we'd probably choose the value of 2.5, which would be the best in this situation. So you'd say 2.5 is the deciding value. So if it's less than 2.5, it's going to be an A. That's why all the A's in that one B, and this one's B. So this one, there's only B's, and this one is mostly A's. So it has the least amount of, uncertainty. It has the most, all the things are mostly together. The only way to get it better is if this B was with its friend, but since we know that's not possible because of the overlap, this is what we're stuck with. So if you were to do this on a larger data set, something a lot bigger, it wouldn't be that easy. You can't just look at it and give it to it. So the computer has to go through all the values of itself, and it just goes through this and sees whatever one is the best. It goes through all of them and finds the best one. And yeah, that's how you do your threshold values. The actual algorithms that are used are talked about in the other ones.